myself Swaranjali Kasre. I am from Ahmednagar, Maharashtra. I have done my bachelor's from Pune University and currently I am pursuing my master's in chemistry from IIT Jodhpur. So our today's topic is Aldol condensation reaction. It is an organic reaction. When we listen about the organic reaction, the first scenario that comes in our mind is there is something reagent will convert, there is something reactant will convert into product using something reagent, or depends on the condition. It should be it may be it's acid or it may be also base. So it's like this: R1, R2, having some reagent. Maybe it may be acid or it may be base, depends on the type of reaction condition of the reactant, and it will give us our product. And in some cases or in some reactions we also get our byproduct. So this is the common scenario which is follow also in the Aldol condensation reaction. So let's see what is the Aldol condensation reaction. It is a reaction in which carbonyl compound is converted into a alpha beta unsaturated carbonyl compounds by using any strong base. So what is Aldol condensation reaction? It is a reaction. It is a reaction which convert carbonyl compound. Which carbonyl compound? Specifically aldehyde or ketones into a alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound in presence of base. So every reaction having some conditions or parameters like temperature, solvent, base, strong acid. So for Aldol condensation there are two conditions which we should follow. Let's see the condition. The first condition is need alpha hydrogen. The compounds which shows or which having alpha hydrogen, that only shows the Aldol condensation. For example, this is our starting compound. We can say this is our starting compound. What is the name of this compound? This compound is acetone. This is our carbonyl compound. The carbon near to the carbonyl compound is known as a alpha carbon. Carbon near to the carbonyl compound is known as a alpha carbon, and the hydrogen present on this carbon is called as the alpha hydrogen. So this compound having alpha hydrogen, that means it satisfies the condition of Aldol condensation reaction. That means this compound can undergo Aldol condensation reaction and use as our product. But if we take the second example, this, what is the name of this compound is? So this is formaldehyde, which doesn't have any alpha carbon and don't have also any alpha hydrogen. So this will not satisfy the Aldol condensation reaction and doesn't undergo Aldol condensation reaction. So this is our first condition. So what is the second condition? Second condition will be need strong base. We need strong base in this reaction. For example, NaOH. These are the two conditions which will apply in the mechanism of solving this reaction. So let's see mechanism of the reaction by using simple example. Let's see example. Step first. There are total three steps which we follow in this reaction. In first step, we take our reactant. Here we take CH3, C, double bond O, and H. What is the name of this compound? This is acetaldehyde. This is acetaldehyde. We take 2 moles of reactant. We can also write this compound as CH3 instead of CH2, and we write 1 hydrogen here. It is the same compound, not different, but we write it into a different form. So we take In first step, we take the base. In first step, we take the diluted base, NaOH. Diluted means base with some amount of water. Base with some amount of water. What is the use of this water? I will tell you in the next step. So what happened in the first step? What is the major work of base? Base subtract the acidic proton. This is the first work of base. But if this is for our condition, another condition is if you don't have any acidic hydrogen, then what the base will do? Base will attack or base will act as a nucleophile. But we have acidic carbon, acidic hydrogen atom. So what base will do? Base will abstract this acidic hydrogen. Base will abstract this acidic hydrogen. This bond will shift here. And what we get? CH2 negative charge, and this compound will remain as it is. So what is the product of this first step? CH2 negative charge. Write it properly. Negative charge. Carbon, double bond oxygen, and hydrogen. Negative charge on carbon atom is called as the carbanion. The positive charge on carbon atom known as carbonation. We have negative charge, so this compound is carbanion. This compound is carbanion. Okay. And when we show the resonance structure of the same compound, resonance structure means just shifting of the charges or shifting of the double bond. We shift. This bond is here. This is electronegative. So this bond will be shift toward the oxygen atom. So what is our resonating structure? Our resonating structure is CH2 single bond, double bond, single bond oxygen, and this is hydrogen. This is our enolate. This is known as the enolate. This is the product of our first step. So let's see what we do in the first step. We take 2 moles of acetate, but we use only 1 mole in the first step. Our 1 mole is remains that we use in the second step. So in first mole, we use diluted NaOH, that means water with NaOH. So base abstract acidic proton. This charge will be shift on the carbon atom, and we get our product. This is carbanion. And when we show the resonating structure of the same molecule, then we get the enolate structure. So we use enolate in our second step. So let's say this is first step. This is second step. Okay. Take that enolate. CH2 double bond oxygen O minus hydrogen. This is our enolate. Oxygen with negative charge. This place is enolate. Enolates are nucleophilic in nature. That means electron rich in nature. So what happens in the second step? We use only 1 mole in the first step, so we use the second mole in the second step. Acetaldehyde. This is nucleophile. What nucleophile needs? Nucleophile needs electrophile. Electron deficient place to attack. So it is our carbonyl compound. Carbonyl compounds are mostly electrophilic. So what happens? This charge will be shift here. This double bond will attack here, and this is partially positive. And oxygen, we know oxygen is electronegative atom, so it abstracts the electron density toward itself and becomes negative. Pi electron density, we can say pi electron density. So what will be obtained? Before writing the product, numbering is the main point, because we will not confuse by writing the product. This is first, this is second. Second will attack on the third carbon atom, and third is connected with 4 carbon atoms. So we total have 4 carbon atoms. So write the product. This is first carbon having double bond oxygen. This first carbon having double bond oxygen with 1 hydrogen. 1 is connected with 2, CH2. 2 is connected with 3. Third carbon having this bond is shifted, that means O minus, and third is connected with 4th. This is hydrogen. Write it like that, but no need of writing. So this is our product. So what happened here? This O minus will take H plus. From where it take plus? H plus. In first step, you remember in first step we use diluted NaOH. Diluted NaOH means water. That means H plus OH minus. So from these O minus take this H plus. That is the use of water molecule. So what we get? We get OH minus. We get hydrogen, double bond carbon, double bond oxygen, CH2, this carbon, OH, and CH3. This is aldol product. This is aldol. Why it is called as the aldol whole product, it is based on our reaction names. The functional group, you should know the IUPAC nomenclature and common nomenclature. So according to IUPAC nomenclature, this functional group is known as aldehyde. So we take ALD from this, and this is hydroxyl group. So we take O here. So this becomes aldol product, right? Now there is a last step of this reaction, an important step of this reaction. So what simply happen in the last step? Last step is condensation step. Last step is condensation step. Take the product that we form in the second step, carbon, OH and CH3. We can write CH2 like CH and hydrogen. Here we applying the heat. What the meaning of or basic definition of condensation reaction? Removal of water molecule by applying the heat. Here we apply the heat on these molecules. So what happened? Removal of water molecule. So these hydrogen which is here and these oxygen will be removed. So there is double bond formation between second and third carbon. So what is our last product? This is CH double bond C H and CH3. So this is our final product. This is known as the carbon atom. Carbon here the carbon is known as alpha. This is beta. So the double bond formed between alpha and beta. So it is known as a alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compounds. So this is the last product. So I revised slowly all reaction. Aldol condensation reaction need 2 moles of starting compound. What is the Aldol condensation reaction? Conversion of carbonyl compounds, specifically aldehyde or ketones, into alpha beta unsaturated carbonyl compounds. So there are 2 conditions for this reaction. First will be need alpha hydrogen for the reactant, and second will be need the strong base in presence of water. So in mechanism, there are total 3 steps. In first step, we do the attack of base on the acidic proton. That will use as our first product, that is enolate. We use the second step, the first product, that is enolate. Enolate act as nucleophile, second molecule will act as electrophile. We get our aldol product. We use that aldol product in third step, do the condensation step, and we get our alpha beta unsaturated carbonyl compound as a final product. So this is all about all condensation reaction. Thank you.